Hello again. This is the second part of the linear regression question. Right, we're on to number 3. At what age would a crocodile be 120 centimeters long? So again, we're using the equation that we've got, and that's that one up there. And this time we're told that the length is 120, so we just put in 120 instead of the L, and we've got 120 equals 14.50 A plus 26.32. Now you can just solve this on these algebra capable calculators, and I will do that in a second. I'll just go through the algebra though separately before I do that way. The way to solve this algebraically, well, I would take 26.32 away from both sides to start with, so I'd get 120 minus 26.32, and that would equal 14.5 A. And then I would divide both sides by 14.5, so that A would be that lot, 120 minus 26.32, all divided by 14.5. And I would at that stage have to use my calculator to find what that come to, and I would get that A equals something. Doing the same thing on the calculator, and the calculator solve, will get the same answer, and I'll just show you how I would do that. If I go over to the calculator now, and I'm at the main screen, but I need the keyboard because I like to get at the solve button by opening the keyboard, going to calc, and then the solve is that button just there, and then I'm going to enter the whole of the equation. So at this stage I'm just going to put in 120 equals, and it has to equal 14.5. I'm going to put X. I could get the A from the alphabet lot there, but it's just easier if you put X for the bit that you're missing, because the calculator is expecting to see X's, plus 26.32. Close off the bracket, and then just get it to solve it for us. And we get that answer, X equals 6.46. Again, I'm going to just go to 2 places of decimals in this question, so I get 6.46, which, if I were to round off, is very close to 6.5 or 6.5 years. And I'm not going to try and be more precise in this question. So it's approximately 6.5 years. I would have got the same answer had I done that division on my calculator. I would have got also the 6.46 in all the decimal places. And that's that. Down to the next part. What does the y-intercept of the equation represent? I'm also looking at part 5 here. What does the gradient of the equation represent? These can be kind of tricky questions. When you're asked that, you're wanting to put it into ordinary language, not particularly or necessarily really maths type terms, though sometimes they are, but try and use ordinary language to describe what they represent. Let's just go back to what we've got here. We've got just go back to the top here. We've got age in years and length in centimeters, and we've got a y-intercept of 26.32. Okay, and we're using this equation. I'm just going to do a very quick, very quick and very rough sketch. That's no good. That should be straight. There we go. And this is years. That's the age, and this is the length. And we've got a straight line with a y-intercept there. It's doing something like that. You will imagine that's a very straight line that I've drawn, and the y-intercept is this point here, and that is the 26.32. What does it represent? Well, along the bottom we've got the age, and at the beginning we start off at 0 and we've gone up to about 10. It's at age 0 we get this y-intercept. At age 0 the length is 26.32. But we won't just say that, because we're going to try and use more ordinary language, and at age 0, for something to be age 0 is when it's born. So when the crocodile is born, that is when it comes out the egg, it is 26.32 centimeters long. So now we've got to go back and write something in English. The y-intercept represents the length of crocodile at birth, or when it hatches, or however you want to say that. The next bit, what is the gradient of the equation? Oh, sorry, what does the gradient represent in this case? Gradients can be a little bit tricky. A gradient is a rate of change. It is something per something. In this case, again, we're talking about saltwater crocodiles, our rate of change is the rate of change of the length, or in more ordinary talk we would call that the growth rate. It is measured in something per something, and in this question it is going to be measured in centimetres per year, because our units are centimetres and years. And I think that's where I'll stop this second part of this linear regression.